Hi, so for today, we are going to talk about velocity, distance, and time worded problems. So this is still a part of our series with intervention for calculus or can be used for the review for the board exam. So for this topic, we are going to just recall the basic formula that distance equals velocity times time, or it can be the rate times the time, the rate at which a particle moves or a person or a vehicle moves. That's the velocity. So we are going to take a recall about this formula where d is the again the distance and r or v is the velocity and t is for the time. Okay, so this relates the three basic parameters of velocity, distance, and time. So for number one, I have 5 problems here and another one for you for your assignment. So later, you can try this on your own and comment down your answer. So for number one, Joey and Natasha start from the same point and walk in opposite directions. So for number one, we have Joey and Natasha walking in the opposite directions. So let's say this is Joey and they say this is Natasha. Okay? So Joey walks 2 kilometers per hour faster than Natasha. So the rate of, let's say, Joey and Natasha, we're going to have a table for that. Okay? The rate of Joey, it says Joey walks 2 kilometers per hour faster than Natasha. So in the problem, the velocity of Natasha is not given. So we labeled it as the simply as R. And since Joey walks 2 kilometers per hour faster than Natasha, that would be R plus 2. That is the velocity. Okay? How about the time? So after 3 hours, okay, after 3 hours, they are 30 kilometers apart. So meaning, they are 30 kilometers apart. So meaning, 3 hours have passed, okay, both for them, and then the distance, of course, okay, that they have traveled should be 3 times r plus 2 because distance is velocity times time. This is your time, this is your velocity. Okay, and for Natasha, that would be 3 times r. Okay, so yeah, that's the distance traveled. And if they are already 30 kilometers apart, it means that the total distance traveled by them, okay, by Joey, D sub 1, and by Natasha should be equal to 30 kilometers since they are walking apart. And that's the total distance of them. So, since we got the distance here, okay, for Joey, because of the 3 times the r plus 2, and Natasha, 3r, that's the distance, again, for the formula RT. So, we now have 3r plus, we have 3 times r plus 2 equals 30 kilometers, okay? So, the problem is asking how fast did each walk, okay? So we are asked for the rate or for the r. So here we have already reduced this into one variable. So we have r, that is the rate of Natasha. And once we get the r, we just simply add 2, and that's the rate of Joey. So we have 3r, distribute this. So we have plus 3r plus 6 equals 30. So combining like terms, you have 6r equals 30 minus 6. So you have 6r equals 24. So divide both sides by 6. You get to have the r. And r is 4. Okay? So the rate of Natasha is 4 kilometers per hour. Okay? So that is what the problem. Okay? Or what we are trying to find, the value of r. And of course, if you know already the rate of Natasha, we can also compute for the rate of Joey. And Joey is r plus 2. So meaning, for Joey, his rate is r plus 2. So meaning, we have the r is 4 plus 2. So you have 6 kilometers per hour. So that's how fast Joey is walking. Okay? So since Joey is 2 kilometers per hour faster than Natasha, so we have these values. Alright, so we did get the correct answer for this. Okay. So for number 2, I'm just going to copy paste this so that we have many space to solve from. Nick and Chloe left their campsite by canoe and paddled downstream at an average speed of 12 kilometers per hour. They turned around and paddled back upstream at an average of 4 kilometers per hour. The total trip took 1 hour. After how much did the campers turn around downstream? So the question is that how much time did they do the traveling downstream? So what happened was they rowed their boat or canoe downstream, and afterwards they go back with the current upstream. Okay? So and then the problem says that they already return after an hour. The total trip return took 1 hour. So we have two kinds. We have downstream, two types of course, the current. So you have upstream. So again, you have the rate here, and of course you have the time, and then you have the distance. Okay, so that we have RT equals distance. Okay, so the rate downstream is 12 kilometers per hour. Okay, that's what the problem says. And then once they paddled back, they are much slower because it's already upstream. The current is against them. Okay? So the total trip took 1 hour. So we don't know, okay, for sure, the total time is 1 hour. But the problem did not state how much time, okay, how much time did they travel downstream and how much time did they travel upstream. Okay? So basically, okay, but the problem only says that the total travel time downstream plus upstream is 1 hour. So that the time in downstream plus the time in upstream equals 1 hour. Or simply, T sub D plus T sub U equals 1. Okay? So, right now, if we're going to do it, okay, and if we're going to substitute it, okay, we don't know the time for the downstream. Okay? So, we don't know the time for the downstream. So, we just label this as time. Okay? And of course, if we are going to have the, let's say the time in downstream is T sub D. Okay? And of course, since the total travel took 1 hour, we can use the situation here, or the, what do you call this? The formula here to get the expression for the time it takes for them to travel upstream. So you have travel upstream equals 1 minus travel downstream. So you have 1 minus time to travel downstream. Okay? So now, the distance is simply their multiplication. Rate times time. So you have 12 times T sub D. And then you have 4 times 1 minus T sub D. Okay? Okay, of course, they've traveled the same distance. Why? Because when they left for downstream to travel to the other side, then they go back from that area upstream towards their time. So they traveled just going back and forth. So the distance is the same. So you have to equate the distance. Okay? So in other words, what I'm trying to say is that the distance traveled in downstream is the same as the distance traveled upstream because they just return back to their original position. Okay? So you have 12 TD or the 12 times the distance in downstream or the time in downstream equals 1 minus T sub D. So distribute. So you have 4 minus 4 T sub D. So combining like terms, you have 12 T sub D. And then of course you have plus 4 T sub D equals 4. So you now have 16 T sub D equals 4. So divide by 16. So cancelled. You have the time for the traveling in downstream. And that is 1 all over 4. So if you lowest term 4 all over 16, that's 1 all over 4 or 0.25 R. Okay? So 1/4 of an hour, that's 15 minutes. Right? But we have in terms of hours, so we have 0.25 hours. Now, how about the time they did for upstream? So looking back in our equation, we have T sub U, which the time it takes to travel going back but upstream. So you have T sub U 1 minus T sub D 0.25. So you have 0.75 hours. So if you plus 0.75 hour and 25 hours, okay, 0.25 hour, that commensurates to 1 hour. Okay, so the question or the problem is only asking for the time for downstream. So our answer for this is 0.25 hour. But just in case the problem also asks the time for upstream, it's 0.75 hours. So it's just logical that they traveled more time during the upstream because the current is against them. Okay? So and they traveled much faster during the downstream because the current is with them in the same direction that they are traveling. Okay, so I think that's number 2. So going back to number 3. So you have number 3 for this problem. I'm just going to copy paste this number 3. Terry leaves his house riding a bike at 20 kilometers per hour. Okay, so Terry leaves his house riding a bicycle at 20 kilometers per hour. Sally leaves 6 hours. So you have Terry and you have Sally. Okay? So again, we have the rate, we have the time, and we have the distance. Okay? So it says Terry leaves his house riding a bike 20 kilometers per hour. That's her rate. Okay? Sally leaves 6 hours later on a scooter to catch him with traveling at 80 kilometers per hour. So Sally wants to catch up with Terry. But Sally leaves 6 hours later. So by the time Terry leaves, let's label it as T, and 6 hours later, Sally started to leave to catch up with Terry. So that means the time minus 6. The time Terry leaves minus 6 hours. Okay? So because that is the time, okay, Sally leaves. So if we compute for the distance, RT equals D, just multiply the parameters. So you have 20T and you have 80 times T minus 6. So how long will it take her to catch up with him? Okay, so how long? That's the time T. Okay, that is the time T. Okay, so if they catch up together, okay, meaning the distance of Terry traveled by Terry should be equal to the distance traveled by Sally because Sally already catched up with Terry. So they have the same distance already. Okay? So you have distance of Terry is 20T equals 80 times T minus 6. So you have 20T, 80 times T minus, we have 480. Okay? Due to 8 times negative 6. So if we transpose this, this becomes 480 positive. And if we transpose 20t on the left side, right side, it becomes negative 20t. So you have 60t, and then you have 480. Divide both sides by 60. And the 60s will cancel, giving you a time of 8, okay, hours to reach Terry. Okay? So, yeah. Sorry. Sa this 8 hours is where Terry traveled, okay, is traveling when Sally catch up with him. So this 8 hours is the time for that is Terry traveling for 20 kilometers per hour when Sally catches up to him. So the question is, how long will it take her? Means Sally, okay, to catch him. That's the question. So this time is for Terry. She has already been traveling for 8 hours before Terry catches up to, Sally catches up to her. But the question is, how long will it take for Sally to catch him? So if that's how long, t minus 6, because that's the time where they have the same distance already. So that would be 8 hours minus 2 minus 6 hours. Okay? So we have 2 hours. So this is the only time, okay, that Sally will catch up with Terry. Okay, with this speed, okay, after leaving for 6 hours. After 6 hours. So the answer here is the 2 hours. So that Sally, okay, can catch up with Terry. Okay, it's 2 hours. It's only 2 hours because Sally is much more faster than Terry. Okay? And as for the reference for Terry, it would take 8 hours for her, okay, before she can be catched with by Sally. So the answer is 2 hours, not 8 hours. Okay, because we are reference to Sally. Okay, so number 4. So John leaves for Chicago at noon and heads towards Bloomington. So yeah, we have John, and then we have the rate. We have the time, and then we have the distance. Okay. So John leaves Chicago at noon and heads towards South Bloomington traveling at 45 miles per hour. Jane leaves. So you have John and Jane. Jane leaves Bloomington heading north. So they are moving in the opposite direction, traveling at 55 miles per hour. So John has 45 mph and Jane is 55 mph. If Chicago and Bloomington are 145 miles apart, okay, then what time will they meet? Okay. So they are trying to reach with each other. So John is traveling south. Okay, this is John. And where Jane is coming from, he is traveling to north. So this is Jane. So Jane is moving at 40, John is moving at 45 and Jane is 55 miles per hour. So the question is, okay, at what time will they meet? So certainly they will meet. Their distance, okay, before they can meet at the starting point is 145 miles. Okay? So, yeah. What time will they meet? So the problem is that John leaves Chicago at noon. So that's the reference time at 12 noon. And Jane leaves here, Bloomington, north. Okay, I think I missed the problem. Okay. Jane leaves Bloomington, heading north for Chicago at 1 p.m. Okay, so yeah, at 1 p.m. So meaning, Jane traveled 1 hour later, okay, than John because John leaves at noon. So this means that that would be t minus 1. Okay? And of course, let's try to get the distance. That would be 45t and then 55 times t minus 1. And they are 145 miles apart. So by the time John travels, okay, that is equivalent to the distance, or no, sorry. Okay, the distance traveled by uh, John is 45t plus the distance traveled by Jane is 55 times t minus 1. That should be equivalent to 145. Okay? Because they are going to meet somewhere. The question is, what time will they meet? Okay? What time will they meet? So let's try to solve for the value of t. So that would be 45 t plus 55t minus 55 equals 145. So combining like terms, you have 45 plus 55. So we have 100t equals 145 plus 55. So that is 200. And you have 100t. Divide both sides by 100. So you have canceled t. So you have t equals 2 hours. Okay? So in just 2 hours, they will meet. Okay? Yeah, they will meet. So again, their distances should be total is d1 plus d2 and the total distance is 145. So imagine John will travel this distance and Jane will travel this distance. So if you add these two, that's equivalent to 145 miles because initially they are 145 miles apart. Okay, so that's for number, I think, 4. For the last problem, for number 5. Okay, so let's try this. So for problem number 5, two train leaves the same station in opposite direction. The first train leaves at 2 p.m. The second train leaves a half hour later. So the second train leaves at 2:30 at a speed averaging 15 miles per hour faster than the first train. By 8 o'clock at that evening, they are 600 miles apart. How fast are the two trains traveling? So to picture, so we have two trains. One train leaves the station at 2 p.m. traveling, and the second train leaves at 2:30 p.m. Okay? Averaging of 15 miles per hour faster than the first train. So we don't know the rate of the first train. Okay? But the second train is much faster than the first train by 15 miles per hour. And then by 8 o'clock, assuming time has passed, okay, and they have already traveled, okay, this is already 8 p.m. and 8 p.m. for both sides of the train. And the problem says that we have a distance already of by 8 o'clock, they are 600 miles apart. Okay? 600 miles apart. How fast are the two trains traveling? So, we are being asked how fast they are traveling. So, the first train and the second train. So, you have the rate and you have this time. Sorry. So you have the time here and you have the distance. So for the rate of the first train, we don't know. The second train is 15 miles per hour faster than the first train. So that's R plus 15 miles per hour. And the time is, the first train leaves at 2 p.m. Okay? So the first train leaves at 2 p.m. So that is certainly certainly 2 p.m. and then after 6 hours, it's 8 p.m. So it traveled 6 hours, okay, by 8 p.m. It's already traveling 6 hours. Now, the second train leaves an hour, half an hour later. So, half an hour means 2:30 p.m. it leaves. And after 8 p.m., how many hours that is? So, 8 minus 2:30. Well, that is 8 minus 2.5. That is 5.5 hours already. And they say that the distance traveled is 600 miles. So from this, we can get the distance 6r and 5.5 r plus 15. That's the distance traveled by the first train and the second train. Okay, so to picture that this is your distance traveled by the first train and this is the distance traveled by the second train. Okay, if we add these two, distance 1 and distance 2, we'll be getting the 600 miles. So that's D1 plus D2 equals 600 miles. Okay? So, for D1 and D2, you have 600 miles. So, if we add D1 plus D2, that would be 600. So, in that, D1 or the first train, the distance traveled by the first train is 6R. Distance traveled by the second train is 5.5 R plus 15. Again, 5.5 is gotten. We solved that because the second train leaves at 2:30. Okay, and we are asked to find by 8 o'clock in the evening, they are already 600 miles. So, 8 minus 2.5, 8 o'clock minus 2.5, 2.5 because 30 minutes is 0.5 hours. So, that becomes 5.5. Equals, you have already 600 miles. Okay, so, getting the R, distributing 5.5 R, okay, and 5.5 times 15, it becomes 82.5. So, 6R plus 5.5, that's 11.5 R, equals 600 minus 82.5. Okay, so this becomes 517.5, okay, and 11.5 R. So, dividing both sides by 11.5 to get the rate of the first train. So, our R is 517.5 divided by 11.5. So, the R is 45. Okay? So, this is 45 miles per hour. Okay? So, this is the rate of the first train. This is the rate of the first train. The second train is, we have R plus 15. Okay? So, our R is 45 plus 15. So, definitely that's 60 miles per hour. And this is now the rate of the second train. Okay. So, that's it. I hope you learned something from this video. And if you find this video helpful, please don't forget to like and to subscribe it with subscribe and share it with your friends. And I have a try it yourself problem here, wherein I have a problem here so that you can practice, okay, solving. And the answer here, so that you can check when you solve it, okay, R equals 20, okay, so 20 miles per hour, okay. So, Alberto can ride the bicycle at 20 miles per hour. So, you should try it and comment down in the comment section if you got the correct answer. So, again, this is Engineer Abat. Thank you so much again for listening. See you again on the next video.